All right, hey, this is Horner, and we're looking at 2000, number 2. You've got a couple blocks that are on an inclined plane. We notice that there is friction because it tells us that right here. And then it's getting pulled down by this bigger mass M. So the first thing that they want us to do is draw and label all the forces on block M1. So that's this block right here, and we're just going to go ahead and move this down a little bit so we can see all those forces. So the first force that we always label is our straight down towards the center of the earth force, which is M1G. We have another force that is moving up and to the left, and that would be our normal force. We have a force moving up the hill, and that would be the tension force. And we also have a friction force that is moving in this direction because the whole thing really wants to move down and to the left. So there are all these forces. Each one of the forces gets a point, so this is worth 4 points total. For part B, they want us to determine the coefficient of friction between the inclined plane and block number 1. So to do that, we've got to kind of look at all the blocks. We're going to put all the blocks in a row. So left to right, here's all of our blocks. And we've got block M1, so this one's going to be M1. We've got block M2, and finally we have block big M. So if you remember from the diagram, we had block M1, and for block M1, let's go ahead and go back up, and let's just draw everything that we can on these blocks in the positions that we see them here, and then we'll transfer it to our sideways diagram. So the first one that we have for each one of them is just the one straight down, so that one's M1G. This one straight down is M2G. And then this one is just big M, G. Going towards the top on this one, going up, is tension. So we're going to call this T1. We also have the same tension coming from this side. It's also T1. Then we're going to have a tension going this way and this way, which is the same, and that's T2 for each of the blocks. Now the blocks also have a normal force, so this would be the normal force on block 2. And we have the normal force on block 1. And then we have friction for each one of these two blocks. So we're going to call this one friction 2 and call this one friction 1. So now that we have all of those fine and dandy things, we're going to move our diagram down, and it says determine the coefficient of friction. So I'm going to put blue dots where we have all of these different forces. Oops, maybe I'm going to put a blue dot here. There we go. And we've got all these forces, and we're going to give them blue dots. The thing that I want to do next is, for this one, I want to define what is our axis. And so we're going to say our axis on this one is up is going to be positive, and then let's also make down positive. So this will be positive perpendicular and positive parallel. The two things that we have that don't have, that are not in the right direction are my M1Gs. So I'm going to draw a line straight down, make that 90-degree angle, and do another one so that I've got two lines that are in the correct direction. So I've put those there, and I've got an angle here and the angle here. And now we can go through and just put our components in. So this bottom side is going to be M1G, and then that is the sine of the angle. This side right here is adjacent, so it's M1G cosine of the angle. We have this side, which is going to be M2G. Remember, it's opposite of the angle, so it's sine of the angle. And then we've got M2G, and we're going to call that cosine of the angle. So now that we have all those in the right orientation, let's go ahead and I'm going to erase what we have here. We're going to put everything in one straight line going left to right. We're going to put all our forces on it again. So let's go ahead, and there's M1, here's M2, and here's big M. So I've got M1, I've got M2, and I've got big M. So going straight up for the first one we said was the normal force. So that's Fn1. going straight down is not mg. Notice it's mg cosine of the angle. So this one is mg cosine of the angle. Going to the right, we have a couple things. I have T2. I also have the force due to friction. And then going to the left on this one, I have M1G sine of the angle. So there's a lot on this one. There's an additional one on this next one. So this is Fn2. This would be M2G cosine of the angle. Going in this direction is going to be tension. And we've got another one, which is, well, actually, let's put tension down here, and let's do M2G sine of the angle. Then we've got two things going in this direction. One of those is T1, so this was T2, T1, and we have the force of friction number 2. And if we read the very first part, we said that this is F, and then this is really 2F. So we're going to get rid of that little 2 down on the bottom because we're just going to call that 2F, and that'll distinguish it for us. And then finally we can draw all the forces on our M here, and this one's really simple. It's just T1, and going in this direction is capital MG. So now we've got everything in a left to right orientation. So we basically took this side and moved it up, and then we took this one and we just rotated it like this so we could get this other diagram. At this point, I'm going to go ahead and erase what we have down on the bottom here so that we can go through and do some things. So there we go. And now they want us to find the coefficient of kinetic friction between the plane and block 1. We know that the force of friction is equal to mu times m. And so what we're going to do here is we need to find out what is N, and then what is it that's equivalent to the force of friction. Let's go ahead and just look at M1 here. And we know that the sum of the forces in the y direction are equal to 0. So the sum of the forces here would be Fn1 minus m1g cosine of the angle is equal to 0. So that comes from this right here, Fn1 minus m1g cosine of the angle, which is going down. So essentially we can say the normal force for number 1 is equal to m1g times the cosine of the angle. Now that I know what Fn is, so that's this guy right here, we can find the coefficient of friction. But to do that, we need to know what F is equal to. So here's the F in question. So let's go ahead and do sum of the forces in the X. So we're going to say sum of the forces in the X direction. And that should be equal to 0 because this thing is moving at a constant speed. So let's go ahead and set everything in. So we've got T2 going to the right, minus, plus, and then we've got F going to the right. And then going to the left, we have M1G sine the angle. So that's minus M1G times the sine of the angle. And that's equal to 0. So we're looking for what F is. So we're going to say F is equal to M1G sine of the angle, because I added it to both sides, minus T2, because we subtracted tension from both sides. At this point, we can go ahead and plug everything in to our equation. So now we're going to have T2. Oops, this is F, so I actually want M1G. So here we go, M1G. So we're just taking what we have right here for F, and we're going to plug it into F right there. So we've got M1G sine of the angle minus T2, and that's equal to U, or mu, times, and then remember we said the normal force is M1G cosine of the angle, so we'll circle that. We know that that goes into N. And so this is U times M1G cosine of the angle. So at this point we need to get u all by itself. If we want u by itself, we've got to divide both sides by m1g cosine of the angle. So I'm going to have m1g sine of the angle minus t2, and that whole thing is over m1g cosine of the angle. Remember, sine over cosine here is essentially tangent. And so we're going to say for this one, well, actually, we've solved for it. So I think we're done. We're just going to stop there. And that would be an appropriate answer for what you need. And so you should be set. So that is the correct answer for letter B. And that would give you all 3 points. You really started with this is 1 point. They want to know what the normal force was. You had to do these other things, and then that gave you the 3rd point, which is right here. For letter C, this one is next, and what they want us to do for letter C, and this is 5 points, is they want us to figure out what is the value that allows the blocks to move, blocks 1 and 2 to move with a constant velocity down the plane. So we're going to kind of try to keep what we've got up top, because we're going to need that here in just a second. We'll make my eraser really big so I can get rid of all this. And now that we're getting rid of all that, let's go ahead and move this down a little bit. Determine the velocity of the suspended mass. So we're looking for the value of the suspended mass. We're trying to find out what is m equal to, so that everything can move down at a constant velocity. So let's go through and set this up. This one's probably the most complicated problem that you'll see all year. But we can make it really easy. And to make it easy, we're going to just use everything going left to right. Constant velocity means that our acceleration is equal to 0. That means the sum of the forces in the x is going to be equal to 0. So let's look at all the forces in the x. If we start on the left, that's negative m1g sine of the angle, because that's going to the left. We're going to add to that t2. We're going to add to that f. We're going to subtract from that. Notice we have m2g sine of the angle minus t2, because there's our t2. We're going to add to that 2 times the friction, which we found right here. And then we're going to add to that t1. We're going to subtract t1. And then we're going to add to that mg, and all that should be equal to 0. So now we can go through and cross off things that are equal and opposite. So t2 is equal and opposite. t1 is also equal and opposite. So let's go ahead and just rewrite our equation again with everything that we know. Let's start with mg. We're going to kind of write it backwards, I think, because that'll help us. So now we have mg. And notice now we have F and 2F, and so that makes 3 times the friction. So we don't have these anymore. We've got mg already moved, and now we're going to take minus m1g sine of the angle minus m2g sine of the angle, and that's equal to 0. We need to solve this whole thing for m. So let's go ahead and move everything to the right that we can move to the right. So this would be m1g sine of the angle. So this becomes positive, plus m2g sine of the angle minus 3f. Let's divide both sides by g, and that will give us our final answer. So that'd be big M is equal to m1 sine of the angle plus m2 times the sine of the angle. And then we're going to subtract off 3f over g. We could then reduce it down one more time. We could just say this is m1 plus m2 times the sine of the angle minus 3f over g, and that's equal to our big M. So that's pretty complex. You've got to do this right. If you don't do this diagram right, you probably won't get the rest of the problem correct. That's actually 5 points. The correct answer here is 2 points. Really doing some of the forces as 0 is a point. Putting putting everything in correctly is a point, and then getting it so that you've got it solved in some sort of way using the algebra is another point. So that's a lot of points for that one problem, or that one part of that problem. Next part that we need to do here is part D. And part D says the string between blocks 1 and 2 is now cut. Determine the acceleration of block 1. So let's go back to block 1. Here's block 1. We remember we said that going down the hill we had a force. We don't have a force anymore going up the hill, okay, other than just friction. So we don't have tension anymore, so we can ignore the tension. And we said that going down the slope, that this was m1g sine of the angle. If you don't remember that, remember we had to draw a triangle for this. We said that this was m1, and then this is the angle. So this is m1g. So this has got to be m1g sine of the angle because it's the opposite side. At this point, we want to find the acceleration. We know the sum of the forces, and let's make this way positive acceleration is equal to m1a. So we're going to do m1g sine of the angle minus the friction is equal to m1a. And so now to get the acceleration of the block, we just solve for a. So a would be equal to, we're going to divide both sides by m1. A is equal to, this would be g sine of the angle minus f over m1. And you actually get 3 points for doing that. So 1, 2, 3. And that should be the end of this problem, and I think that's it.